Good morning, good afternoon, good evening. This is Mr. Payne bringing you regressions, residual and correlation coefficient, final exam review number 6. We're talking about our different regressions. Don't forget we have our three major regressions. We have our linear regression, we have our quadratic regression, and we have our exponential regression. The two regressions that you will use the most are my linear regression and my exponential regression. Now remember, we are talking about at this point in time the word regression. Okay, we're not talking about residuals yet, so we're talking about our regressions. One of the things that we got to remember when we talk about our regressions and we're trying to get our regression points is that we're going to utilize stat calc 4 for linear. So let's write that in there right below it. Stat calc 4. And then for my quadratic, we're going to use stat calc 5. And for exponential, we're going to use stat calc 0. Now remember, all this information can be put into our calculator. A couple little notes that I want you to remember is that along with this regression, when can we use it during the regular school year, besides in our statistics unit? Well, for our linear model, don't forget, and I'm going to write it up top, that we can use our linear regression to help us with arithmetic sequences. Arithmetic sequences. And for exponential, we can use the exponential model to help us with our geometric sequences. Not all geometric sequences work with an exponential regression. However, they do go hand in hand because of the multiplying of the constant rate. So those are little hints to help us with things outside of the statistics unit. We could also at any time plug a table in either the exponential unit or the linear unit into our linear regression and get our equations without having to know my slope or my b or calculating that. And the calculator will tell us all about that. Now how to get the equation in the line of best fit and rate it. That's the key word here that we're going to talk about today in rating it. That goes along with the word correlation coefficient when we talk about rating it. So whether you're given a graph, whether you're given a graph or a table, you have to find the points. Find the points that are plotted there. Enter the data into my L1 and L2 by hitting stat enter, don't forget. To find the equation, then you hit stat, and don't forget that right arrow means you're going to hit calc, and that's what I normally say is just stat calc. And then the number of regression you wanted, and then enter, enter, enter. Remember I gave you 4, 5, and 0 on the front page for that regression that you want. Now let's talk about my correlation coefficient, the most important thing. In the beginning part of the exam, your proctor, no matter where you're taking that exam in whatever room, is going to read to you, at this time, please turn on your diagnostics. And that's going to be super important. You have to do that by turning the diagnostics on by hitting second 0, scroll all the way down to diagnostics on, and then you have to hit enter twice. So I'm going to put times 2 there. You have to hit enter. You want to hit enter until it says diagnostic on, done. Do the regression you choose just by following the steps up above and look at the R value. I don't care about the R2 value. I care about the R value. If the R is close to -1 or to +1, it's very strong. The closer to 0, the weaker it is. So if I'm going to draw you a little model right on the bottom, there's 0, there's -1, here's +1. As we grow this way, the stronger we get. As we grow to the left, to the -1, the stronger we get. So weakest is closest to 0 on both sides. Alright, think about that. If you're not sure about your decimals, you say, okay, is that closer to $1 or is that closer to 0? And that's what you want to think about. So if it's 89 cents, 0.89, or negative 0.89, I'm going to use that as an example, 0.89, or negative 0.89, and remember they're one of the same, just having negative just tells us what kind of slope it has. Is that closer to $1, or is that closer to 0? I hope you could tell me that it's closer to $1, so it's more on the stronger side. It's not perfect, okay, but it's stronger. Remember that my ones, my positive one and my negative one, are my perfect correlations. Those dots will be in a nice tight line. The next word we're going to talk about is residual graph. Now, my residual graph is much different than my regression graph. If it's a true scatter diagram, it is great. If it forms a pattern, the wrong regression was chosen. So let's hit pause and go look at some examples. Here's what I'm talking about with the residual plots. I have a good residual plot and a bad residual plot. This is a good one because it has no pattern. Because it has no pattern. Okay, it looks like a true scatter plot. The dots are on both sides. And here's my residual line right here. This is my residual line. This is a bad line of a bad residual plot. Remember, this is a plot of residuals. Okay, this is talking about residuals. This is not a scatter plot. This here shows some type of pattern. So this is a bad residual plot because it has a pattern. All right, and the reason for that being a bad one is because they chose the wrong linear regression model. So they may have chosen linear, but it was exponential. And that could be, sometimes those are tricky depending on the data. Thank you very much. Now complete the rest of the questions in this packet to the best of your ability. I know you don't have a calculator at home, but see if there's any ones that you can. If you're in study hall, try to borrow a calculator. Have a great night.